Hello everyone and welcome back to my channel. In today's video, I want to show you 4 very common reasons why your timer interrupt might not be working on the C2000. This is one of the most frequent issues I see with beginners. The code looks correct, but the interrupt never fires. I will go step by step through each mistake, show you the wrong and the correct setup, and explain how to debug it directly inside Code Composer Studio. Let's start with the first one, and I will also show you how to verify it on real hardware. First mistake is that your peripheral is might not enabled. On C2000 devices, every peripheral is clock gated by default. That means even if your system clock is running, the CPU timer will do nothing unless its peripheral clock is enabled. You can verify this by checking the peripheral clock registers in Code Composer Studio. So before debugging anything else, always make sure the module clock is turned on. Let's now see how to check it and what might be indication that your clock is not enabled. Here is shown one project inside which we have the system clock initialization, GPIO, XBAR and the timer initialization. And inside the system initialization clock, I disabled the peripheral clock for the timer 0 so that we can see how this reflects to our timer 0 configuration. And we will see how to debug and conclude that actually our peripheral clock is disabled. Let's now go to the debug. And let's now step to the code where we initialize our timer. And before we step further, we will open the registers and then we will go to the CPU timer 0 registers, and here we will enable the continuous refresh, and we will observe what is happening with our registers while we try to set some values inside those registers. So let's then step through the code. What you can observe is while I'm stepping through the code and using TI's libraries, my registers from CPU timer 0 does not change. And this is actually the indication for you that this means your clock is might not enabled. And this is not only the case on the C2000 microcontrollers, this is usually case for any other microcontroller. So if your clock is not enabled, this would mean you will not be able to write to the registers, or the values inside your registers will not be changed. The next what you can do, you can check the clock enable bit, which you can find inside the CPU system registers, and specifically for timer 0 you can find it here inside register PCL KCR0. And here under the CPU timer 0 you can observe here is 0 and CPU timer clock is not enabled. Okay, let's now fix this. Inside the HAL system.c file, I have here the disabled peripheral for our timer 0. And here I will now remove this and enable the timer. What shall be pointed out is that for timer 0, 1, and 2, the peripheral clock is enabled by default at the beginning. So even if you don't call this function, your clock will be enabled for your timers. But in any case, we will do it because it's a good practice to have it inside the code. Let's now go to the debug and see what is different compared to the previous case. We will step also to the HAL timer init function, and here we will open the registers. First, what we will check is if this bit is set to 1. Yes, so now our CPU timer 0 clock enable bit is equal to 1. And now we will observe our registers for timer 0. when I step through the code, now you can see that something changed. Okay, now we should see after the next step, you should see the period value is changed. Yeah, so we can now see value 9999. It is actually what I'm setting. Okay, so this was the common mistake number one. Let's now see what is the common mistake number two. The second mistake, your timer works, but the ESR never executes. That's usually because interrupts aren't enabled through the whole chain. The C2000 interrupt system has three layers. The module interrupt enable, this is inside the timer, the PIE group enable, and the global CPU interrupt enable. If any of these is missing, your interrupt never reaches the CPU, even though your timer is working fine. So first, the level where we enable our interrupt is at the peripheral level. And for our CPU timer number 0, this is actually inside our HAL timer init function. And this is calling this function CPU timer enable interrupt. By calling this function, we enabled the timer at the peripheral level. The second what we need to do inside our main function, we need to enable the timer interrupt at the PIE level. And this is a location where we do it. And the third is that we enable the global interrupt at the CPU level. And this is the location here. If any of these three is not enabled, your interrupt will not work correctly, or timer will work, but the interrupt will not be fired. Let's now try to disable one of these, and let's try to see what will happen. My timer interrupt is inside tmr example.c file, and here I will hit the breakpoint, and let's now see. So I never reached this point, and this is because my timer is working. We can check it if we go to the registers, and if we see here that our timer value is changing, so timer is running, but my interrupt is never fired. Let's now try to return back, and let's try to see again. And now you can see, if I step, let's say, one step ahead, and then again, so my timer is firing, or timer interrupt is firing. Let's now see the third common mistake. This is a subtle one. Your interrupt executes once, then stops forever. That usually means you forgot to acknowledge the interrupt group in the PIE controller. After servicing an interrupt, the CPU must tell the PIE that it's ready for the next one. Without that acknowledgement, the PIE keeps the flag set and blocks further requests. In this example, we will show what will happen when we comment out the interrupt clearance for acknowledge group number 1 inside the PIE block. So let's go into the debug. First, what we will do inside the interrupt, here we will hit the breakpoint, and then we will run the code. You can see first time we entered the interrupt, and if we click now run, we never enter again inside our interrupt, and the reason is because we didn't clear the acknowledge group. And if we do the same, we just acknowledge the group, then our interrupt will be firing one after the other one. And this is the first time, second, third, fourth, and so on. So the interrupt is firing. And finally, the fourth common mistake is the system clock itself. If the PLL or system clock out isn't configured correctly, your timer may run way too slowly or not overflow at all. This happens often when still running on the internal oscillator at 10 MHz, but you think you are running it on an external oscillator. Once the system clock is correct, everything else falls into place. And this connects perfectly to my other video about the C2000 clocking system. You will find the link below where you can see how you can check if your clock is configured correctly. So these are the four main reasons why your timer interrupt might not work on the C2000. Check them in this order from the peripheral clock to the system clock and you will find the issue quickly. If you want to understand the full system, clocks, interrupts and peripherals step by step, join my C2000 basic course on hkacademy.com. Use coupon code, which you can find in comment below, for additional 20% off until 11th of October. Thanks for watching and see you in the next HK Academy video.